as heap. Okay, and what we will do is that, and there are few things, guys, just to kind of note down, is that if you see for the memory range, so this is actually the range, the starting value, and this is the ending value of how much memory will that a.exe will occupy in the RAM memory. So that range is something which is mentioned over here. Okay, and if you see, this is a high range and this is a low range. Okay, so this is something like, let's say from 1 to 5. Let's say this is 5 and 1. So this is the space where the whole data will be stored. Okay, and thing is that few things just to know, that the stack memory, it actually grows dynamically. This memory is not like a static. It actually grows dynamically, and it grows from high to low. Okay, it grows from this part this way to this part, where the heap memory, it also kind of expand depending on the software code, and it expand from low range to high range. Okay, and whenever you guys, let's say, see certain kind of error like segmentation fault kind of error, you might have kind of noticed. So thing is that why you receive that is because when this stack memories grows, they have a certain kind of a deadline where by which deadline over here internally. So if the memory grows at a point where it is almost about to touch this deadline, that's where you get actually a segmentation fault in your system. Whenever you see any kind of segmentation fault error, that the software has kind of stopped working. The only real reason is that this is either the stack memory or either the heap memory has kind of grown a lot and they have touched their deadline. Okay, and that's where the operating system actually halt the execution, and it raises the segmentation fault error. Okay, and it stops the software from getting executed further. Okay, because in that case, what will happen in the stack memory will override the heap memory, or heap memory will override the stack memory. Okay, so that's all about like how the softwares, once it is loaded from hard drive to RAM memory, how the things are kind of stored over there. So guys, the other thing is that there were a lot of other theories part that actually I have actually planned earlier to kind of discuss about a vulnerability assessment, but I have been kind of changing that kind of changing the syllabus a bit, like where I have been devoting more time in kind of implementing a lab for you guys. Okay, so I'll be kind of trying to keep the session interactive. It will not be just theory; it will be a lab part, so that it will be, kind of it is much more interesting, as well as it actually addresses your concerns that we have been kind of receiving kind of earlier. Okay, so with that in mind, thing is that what we'll kind of doing is looking at the lab part in much more sense. So let's not worried about the theory part. Like I have been kind of dealing with theory a little bit, but just to kind of just an FYI, there was 10 to 15 times more theory which I have planned in the vulnerability assessment part, specifically for you guys to kind of deliver, which I have prepared. But I have kind of removed that with a mindset that that kind of delivering the lab is something which was kind of requested. So thing is that little bit theory will still be there, which I'm just trying to kind of complete that, so that when I'll be kind of dealing with the lab part, like this one that you see over here, the lab part and all. So we will be kind of able to understand that. Okay, so we can't let's say avoid the theory the full. At least we need to know certain basics, so that the lab, when we are doing, it's much more clear. Okay, but just to let an FYI, there were like 10 to 15 times more theory that I have prepared. I have kind of disregarded that, just to kind of keep the session much more interesting and give you guys a much more lab feel rather than just the theory feel. Okay, so thing is that now what we are going to do is look at the things in much more detail. So give me 1 second. Let me just quickly see what else I need to discuss from this slide. Okay, so now this is the stack memory, like what I was talking about, the stack memory, where I told that it grows from high to low. Okay, so we'll try to see how the stack memory actually look like in a much more deeper way. But before that, I will take a, let's say, 2 to 3 minutes break. I'll quickly grab some water, a little bit feeling tired. So, and then we'll kind of resume our discussions. Okay. So give me 2 to 3 minutes. I'll come back post grabbing some water. Okay, guys. So now let's resume the discussion. So in the we were discussing a little bit. We started a little bit discussing about the stack memory and all. So we'll try to see a little bit in much more detail what stack memory is all about. So thing is that, as I told, the stack memory grows from high memory to low memory. And thing is that in the stack memory, thing is that it is divided into chunks of data. Okay. So thing is that if you are dealing with a 32-bit CPU, if you are dealing with a 32-bit CPU, this stack memory will be divided, will be having the space of, let's say, 32-bit. Like it will be divided into multiple chunks like this. Okay. For an example, and let's say each chunks will be of 32-bit. Okay, each chunk will be a 32-bit space. Okay, and thing is that, as I told, like this memory has a limit, but it grows from high to top to low. Okay, and I hope, guys, I'm audible, everything's good. Yeah. So thing is that it grows from high to low, and what happened is that thing is that how the computer will keep track of that how much the memory has growth of. So at initially, even though this stack memory limit is this much, the size will be 0, right? There will be no data. And let's say there are two kind of data